The following is an overview of the Photonix Technologies lineup of fiber optic leak detection devices. The first of these items is the familiar VFL or visible laser light source. The second is the Lighthawk infrared leak detection probe. And the third is the flash pistol leak detection probe. We also have the flash pistol infrared tracer source for use with the Lighthawk and flash pistol products. Depending on the application, the technician may choose one of these three items for short, medium, or long-range leak detection applications. Leak detection may include the detection of bends, breaks, leaks around bulkhead adapters, or end-to-end testing for continuity. The Photonix VFL works at 635 nanometers in the red region, and any bends, breaks, or leakages within approximately a 5-kilometer range are fairly easily detectable. The device can be used for end-to-end location of fibers, and it can be used for location of breaks in light-colored fibers. Here we are checking the continuity of a section of communications cable. Splice leakage, leakage from bending, and leakage from fiber breaks. In a common demonstration, a patch cable here is broken and you can see the amount of light thrown off from that break. One of the fundamental limitations of VFLs is that they have trouble finding bends and breaks in blue, green, brown, and black buffered fibers. In this example, the VFL is shining red laser light through this blue sample, and there is a break in it and it's not visible. In this example, we have a strand of 250 micron black buffered fiber with red laser light going through it, going around a mandrel. While there is a slight bit of red leakage coming out, it is very difficult to see and it would be nearly impossible in sunlight. Another limitation of VFLs is their distance. Here we have a 10-kilometer spool of fiber, and we are seeing no light coming from this scattering termination. The light would be difficult to see in approximately a 5-kilometer distance, even less in bright sunlight. In a situation where mid-span troubleshooting is required, it is possible to use a visible laser source if you are within a few kilometers of the actual splice enclosure. A little bit of red light will leak out where there's damage, in this case at a breakout point. And in this case we can see the light leaking from a damaged fusion splice. This is another example of the leakage that could be visualized in a mid-span splice enclosure. Again, these are all over short distances. Now we are looking at the same fault using a red laser light source, the VFL, after 10 kilometers of fiber. It's completely invisible at this point. And with the fault at the breakout location. After a few kilometers of fiber, you can see that the VFL is limited in its performance. The same is true with this splice. The final concern with a VFL is the fact that it works in the visible region. It's the same region that our eyes are obviously most sensitive. Because of this, there is an eye safety risk in spite of the fact that they are Class 1 devices. Careless use of a VFL could pose potential problems. Infrared sources at the same power level do not pose nearly the same risk. This is where the flash pistol and light hawk probes come into play. These devices work off of infrared light. A tracer signal that is infrared, usually 1550 nanometers, will be injected at the head end. The light hawk probe will probe and detect signals as low as -67 dBm. The flash pistol performs the same function, except it will function down to -80 dBm. Used in conjunction with a variety of Photonix tracer sources, it is possible to achieve up to 90 dB of budget. With a budget of that magnitude, it's possible for the technician to troubleshoot splices, bends, and breaks at a distance of over 100 kilometers. It is also possible for the technician to test end-to-end for continuity at distances of greater than 300 kilometers. In order to see what this means in the real world, we take the same blue strand of fiber that we used the VFL on earlier and couldn't find a break in, and this time we use a 1550 nanometer tracer source modulated at 2 kHz. We also use the Light Hawk leak detection probe, and we'll scan that same fiber. We can detect that break from a distance of approximately 18 inches. And here we use the flash pistol leak detection probe to perform the same task. It too sees the break and can see that break from a distance of up to 10 feet. Here we are revisiting our black buffered fiber. And using both probes, we're able to pick it up easily. And here we're revisiting our black buffered fiber. That is using the Light Hawk probe that would be detected up to 6 inches away. And the flash pistol would work from up to 1 foot away. And here is the same mandrel being used to test after 10 kilometers of fiber. And here we have the same black fiber after 50 kilometers. And here again we have the scattering termination, except this time it's not just 10 kilometers, it's 100 kilometers away. And as you recall, we were not able to see this at 10 kilometers with the visible laser source. And here we are at 150 kilometers with the flash pistol. And here's the splice enclosure again after 10 kilometers. As you recall, this is the situation where the visible laser source didn't work, but with the Light Hawk, we're able to see that tracer tone, and we'd be able to see it at upwards of 100 kilometers. The same holds true for the damage at the breakout point. And again, fault locating fusion splices. And here we're testing the continuity of an unterminated fiber over 80 kilometers. The flash pistol and Light Hawk can be used for fiber tracing at distances of up to 150, 200, or even 300 kilometers. Here we have a situation where there is damage underneath the boot on the orange strand. In this case, we're looking for a fault in a brown buffered fiber, And with a red visible laser, we would not be able to visualize this. Aside from fiber tracing, it is possible for the Lighthawk and flash pistol to check ports for activity. This is a non-contact test, and will tell you if there's infrared present on that port. And that concludes our overview of Photonix leak detection products. For more information, please visit Photonix Technologies at www.fiber.cc or contact Photonix at 1-800-404-5868.